This is number 8 from the review. The first thing you want to do on this problem is factor, just like on all the others. So we want to factor to see if we have anything that cancels. The top, we need two numbers that multiply to negative 12 and add to positive 1. That's positive 4 and negative 3. On the bottom of our fraction, we already have that x minus 3. Then we need to multiply to negative 4, or multiply to positive 4 and add to negative 4. So that's x minus 2 and x minus 2. From this, we know that we're going to have a whole at x equals 3. Because x equals 3 cancels, that gives us a whole. So I'm going to go down here and say 3, and I'm just going to leave that y blank for right now. We'll come back and fill that in a minute. The top here gives us our zeros. So we get our zeros from setting these two equal to 0. So our x-intercepts are x equals 0, so 0, 0. And x equals negative 4, so negative 4, 0. We get our vertical asymptote from the 0 of the denominator. So if we look at the bottom here, we have x minus 2 twice. So that's just going to give us one vertical asymptote at x equals 2. And the last asymptote we're looking for here is a horizontal asymptote. We know we have a horizontal asymptote since the degree of the numerator of our fraction is the same as the degree of the denominator. So just to look at that for a second, here on top we have x times x squared. So our numerator is x cubed in degree. And on the bottom, same thing, x times x squared, so that's x cubed. So don't let the fact that it's already partially factored throw you off. We have the same degree on the top and the bottom. When we have the same degree on the top and the bottom, the horizontal asymptote is just the ratio of the leading coefficients. So really here I have a 1 in front of this x, and I have a 1 in front of that down here. So 1 over 1, our horizontal asymptote is y equals 1. All right, let's go back to this whole situation and finish it. We know that for our whole, we have x equals 3, but we don't have the y value. The way you find the y value for the whole is to you take your function that you have left over after you cancel. So what we have left after we cancel is x times x plus 4 over x minus 2, x minus 2. That's what we have left over. And what we want to do with that is plug in 3 and see what we get out. So when we plug in 3, we get 3 times 3 plus 4 divided by 3 minus 2 times 3 minus 2. When you put that in your calculator, make sure you put it in exactly as we made it look here as a fraction, or you're going to want to use a second set of parentheses around the denominator. I like the fraction button in the calculator. And when we put 3's in for all those x's, we get 21. So our whole is at 321. At this point, I would graph it and confirm everything that you've found so far. I would make sure that my asymptote is where I expect it to, both asymptotes are, and that the zeros and the are where we expect them to be. You can also look in your table for that whole. Again, the whole, your table is going to look like this. 3, oops, that's xy. 3, and error. So make sure you have an error there at 3. You should also be able to see the pattern for the y's and see that 21 would fit in there nicely. We want to find the y-intercept. Here, when you graph it, if you just hit trace, you'll get the y-intercept will pop up automatically. The y-intercept is 0, 0 for this function. You might be thinking, we said there's a horizontal asymptote at 1, and when you graph it, your graph crosses the horizontal asymptote, and that's okay. Remember, our graph can cross a horizontal asymptote at a single point, because the horizontal asymptote is about what's going on way out at the infinities. It's about the end behavior of the graph. So this graph does cross the horizontal asymptote between x equals 0 and x equals 1, and that's okay. We haven't done anything wrong. The last thing we want to do is domain and range. Here, our domain, we just need to exclude our asymptote. So our domain is negative infinity to 2 and 2 to infinity. And for the range, you need to find the minimum there. You have to be really careful. Just use the minimum, do calc min, and find the minimum. And it's in there between -4 and 0. And when you do that, you should find that the minimum is -1/3. And our graph is going to infinity. Again, I can't show you the graphing calculator stuff using this application, so if you have questions about that, please see me before the test.
Made with Doodlecast Pro.